All right, this is Team 11, and we worked on the coffee bot this semester. I am Noah Tinker, and I'm with Victoria, Coleman, and Chris. So for our project, our primary objective and our main motivation was to make a coffee system that integrates servo motors, a Raspberry Pi, specifically a Raspberry Pi 4, wireless communication, this is done via Wi-Fi, and then a mobile application, which we developed on Android devices with Java. So we wanted to get a ready-to-go coffee when the user wants it with a wide range of functionalities. So we included a button that presses to brew the coffee. We have syrup and water dispensing, a lid opening and closing, our conveyor belt, and then our app has tons of options for the user to customize what they want their brew to look like. We wanted it to be consistent. We wanted it to be real-time, precise, and user-friendly.
Now looking more at some of the specific goals and deliverables, we want to deliver a fully functioning coffee robot that uses a user-friendly Android app. This would demonstrate the ability to control the coffee bot using an Android app, programming using Java. From that app, it would then precisely control one DC motor and 5 positional servo motors that would then make a customized cup of coffee through a fully automated user-initiated process. Some of the tasks that the coffee bot will do is being able to open and close the lid of the coffee machine using a servo motor. It can brew a coffee based on user designated selections, which were made via the app. It will move the coffee cup to the syrup station on a conveyor belt. The conveyor belt is then stopped using defined DC motor degrees of rotation. And then the last thing the coffee bot will do is dispense the flavored syrup into the cup using servo motors based on how many pumps of syrup were entered into the app. Now, our Android app will allow the user to wirelessly communicate with the Raspberry Pi. This will happen over Wi-Fi. Within the app, they can choose from 2 different flavor syrups, and within that, they can choose how many pumps they want. Then they can also choose from 3 different sizes of coffee, 8 ounces, 10 ounces, and 12 ounces. Then there's the wirelessly initiating the coffee brewing, allowing the user to pick a cup of coffee to be brewed at a specified future time, as well as saving the brews as a preset for future brewing. And this is a picture of our full implementation with the coffee machine, the rail system to move the coffee cup, and the syrup dispensers.
All right, moving into the block diagram, this is kind of showcasing the data flow of our entire system. So looking at the Android phone to begin with, this is where our Android app is hosted on. The Android app is sending the user's coffee data to our Raspberry Pi, which is then, it handles all the servos and motors. And we start out with the DC motor, which is controlling the cup conveyor. Once the cup moves all the way down to the flavor dispensers, the syrups, the vanilla and caramel are dispensed into the coffee. Our cup conveyor then moves the cup back to the brewing position, and the lid opens for us to put our coffee in. The water starts dispensing based on the user's selected size of coffee. And finally, after everything has been put into the machine, the brew button is pressed.
Now, in terms of the hardware design, we had 5 servo motors. Each servo was running at 5 volts DC, and these 5 servos were used to open and close the lid, dispense the water, 2 servos to control the syrup pumps, and then 1 to press the brew button. We also had 1 DC motor operating at 12 volts DC using a Raspberry Pi 4 as the main controller, and using an L298N motor driver with the Raspberry Pi to power our DC motor. We also used a variety of 3D printed parts to help protect the electronics and wires from liquids. The Raspberry Pi and a breadboard were housed in that waterproof box, which protected the Raspberry Pi and other electronics from liquids. So the majority of our physical system was 3D designed using SolidWorks and 3D printed, which over the next 3 slides, we have here the rail system, which was designed in SolidWorks. So that's the DC motor mount as well as the sliding conveyor belt system. This next slide is the brewing arm, which mounts on the side of the coffee bot and presses the brewing button. And then the final 3D printed part that we have showcased here is the syrup holster. So the syrup bottles slot in there, and then we have servos mounted at the arms on top to dispense the syrup. Additionally, we have 5 180-degree positional microservos, like we said, operating at 5 volts DC through the Pi 4. And we also have one 12-volt DC motor controlled using the L298N motor driver. And this next slide has our wiring, which is inside the black box at the back of our design with the L298N motor driver, the Pi 4, and the breadboard all slotted in.
So for our software design, we broke it down into three main components. And as we've mentioned, those three main components are the app, which was written in Java, the Flask server, which is written in Python, and our system code, which is written in C. So the Java takes all the user information, it forwards it to the Flask server, and then the Flask server executes the system code in C, which runs our system. So for our app, we programmed it using Java, and then we communicated with the Raspberry Pi via Wi-Fi. So the options that the user can select are two different types of syrup, vanilla and caramel. You can do up to 10 pumps of each. They get three sizes, which is the size of the liquid going into the coffee, so 8, 10, or 12 ounces. They can brew the coffee now, or they can set a future date up to 24 hours later to brew their coffee. So the idea would be you could brew it tomorrow morning. You have an option to save your brew as a preset, so you can save it. Then there's a whole separate tab, and we'll go over this later, that has your saved preset, and it tells you the settings you selected. And then you have the same options. You can either schedule it to run in 24 hours, anytime within there, or you can brew it now. And then you can also remove those presets if you need. So the app has three primary activities. If you've programmed in Java, you know what I'm talking about. If not, activities are just screens. So the main activity takes us to our new brew screen and our saved brew screens, respectively. Our new brew handles all the interactables, the interactions. It sends the request to the Pi and it saves presets. By interactables, I just mean buttons and sliders, and the interactions being a button press and a slider move. Same with the saved brew. It has all that same stuff plus the preset data where you can delete or you can load from the list of presets. So these are what our screens look like. The one on the far left is our main activity. And then you can see the two buttons on the top, one to new brew and one to saved brew. Those are two separate activities in themselves. The one next to the one on the left, so the second one, is our new brew. That's where you can select all your options, and that's where you have the option to save your preset and you give it a name. The one next to that, so the third one, is our saved brew, where you can select from your presets. Same thing, you can schedule it, or you can brew it now. You can remove your preset, and then you can see under the delete preset, it explains to you the options that you selected for that preset. And then finally, the fourth picture is what it looks like when you schedule, and you can see it's in 24-hour time, and you simply just pick it, and it will run at that time.
So our next set of code was the Flask server. This was written in Python, and it's the mediator in between the Java app and the executable code to run the system. So the Flask server receives JSON requests from the Android app. It receives the size, vanilla, caramel, as well as the execution time. So then it adds the size, vanilla, and caramel values to a database. This database is used such that you can schedule future brews while still being able to access the saved values for a brew that will be happening sooner. Then it checks if the current time is the execution time. If it is, then it runs the thread that corresponds to the execution time, and then that further runs the executable file, and it passes in the size, vanilla, and caramel as command line arguments. But then if it is not the execution time, then it just keeps comparing in an infinite while loop. Every second it compares the execution time to the current time.
All right, so looking at our system code, there was three main segments. The first was to parse and check the command line arguments. This was helpful because we needed to communicate between the Flask server and the motors. So the command line arguments was communicating this information. We needed a section to control the conveyor or the DC motor. And finally, we needed a section to control the syrup dispensers. And some of these images down here are showcasing the helper functions for each of these. All right, moving into our results. So we were able to have all the user inputs be accepted via the Android app successfully. We had wireless communication to the Raspberry Pi via the Flask server, and this is done over Wi-Fi. The Flask server receives a JSON request from the Android app and then uses these values as command line arguments when we were running the executable or the source code. We then had 5 servo motors, which all operated at 5 volts DC. And these positions for the servo motors were set using the Pi GPIO C library. And then we had one DC motor for our conveyor operating at 12 volts. And then the speed and direction were also set using the Pi GPIO library.
So now looking at some of our challenges with the design, we had a lot of physical design constraints. One of our hopes was that the user could select a type of coffee, whether it be decaf or normal, but we were unable to mount a hopper for the coffee selection above the coffee maker just due to the size and challenges with that device. We also were unable to implement a stirring mechanism just due to the fact that there was too many degrees of freedom and need to tilt the mechanism into the cup as well as spin it. Then we also dealt with conveyor belt tension problems where we go slack as the belt was sliding. And then our final problem ended up being that there wasn't enough force to press the brew button, so we had to create a new arm that would press the brew button. And finally, our conclusions. We were able to successfully implement the coffee bot prototype that included the following functionalities. We could customize a brew using an Android app. We could dispense water as well as 2 syrup types. We can move a cup along a conveyor belt system using a DC motor, and we can initiate a system via pressing the brew button on the coffee maker. Then throughout the project, we had skills that we use in Gain, in Python, Java and C, SolidWorks, circuit design, as well as system design and testing. So next we will show a demo of our working prototype. This includes both the system as a whole, as well as a better view of the brew button, since it's hard to see how it starts. And here are our references. Thank you.